Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our Linux Foundation Certified System Administration exam preparation. In this video what we're going to talk about is we're going to be talking about how to manage user account processes. So user processes are anything that a user starts rather than a system starting on the system. However, you'll notice that even system processes have an associated user. So one of the most common ways of seeing what is running on a system and then managing it is using one of two things, either the top or htop process. So let's take a look at what top looks like. This gives a running view of all the processes by process ID and by user and its particular setting in terms of priority. In this case priority is 20. Now a 20 priority is the lowest priority on a system, whereas a minus 20 priority is the highest priority on a system. And you'll always notice that the first PID or PID, the one with the number 1, is always the init command. The init command is the father of all commands on your system, and it will always be PID number 1. Generally you'll see kthread as the second one, but you could see one of these other ones or one of the kworker threads as number 2, depending on whether it's a physical or virtual machine. The top application gives us information about everything that's running. So we have 96 total tasks, 1 that's actively running, 95 are sleeping, none are stopped, none are zombie, whatever our load is. In this case, this virtual instance is not doing a whole lot right now. We've got limited memory, no swap in use, etc. That's good information, but htop formats this a little more friendly. So let's see if we have htop installed. We do not. So what we want to do is let's su to root, and we will actually install the htop package. We happen to be running an Ubuntu 14.04 LTS system. So in our case, it's going to be an apt-get install htop. On a CentOS system, it's simply going to be a yum install htop. Htop is available in the standard distribution repositories for every major distribution you'll find out there. So once you get it installed, you'll be able to run it just fine. Now this gives us a little more of a concise version of what we saw with top. It tells us the number of tasks, how many are threaded, how many are running, which we saw before. We only had 1 running. Our load average is basically nothing. This gives us our used memory as well as our available memory, how much is in swap, how many CPUs we have, and how much they're in use. You'll notice again that doesn't change the PID, and it will always run as the number 1 process on the system. And then it tells us what users are associated with the different processes that are running on our system. So it's a good overview of what happens to be going on our system. However, a lot of times you'll see that top and htop, although providing a nice interface to running processes, they're not always flexible enough to adequately cover all the scenarios. So you'll also see commonly in use an application command called ps. So if we execute ps, the output is a little bit plain. It just gives us what my particular user happens to have running on the system. What happens if I'm the root user? Let's do root and log in and just do a ps. Well, we've only got su, bash, and ps that are running, so it's pretty plain. It just shows all of the processes associated with the current user and the current terminal session, which is why I don't see a whole bunch of stuff running even though I'm running as the root user. So to get a more complex and complete picture of the processes on this system, we'll run the following command, which is the one that you'll see most often run, is ps aux. Now this gives us a full set of options to show all processes run by all users regardless of their terminal in a little bit more of a user-friendly format. If we want to see a tree view of those processes, let's go ahead and clear this up. We can do a clear, and we can do a PSAXJF, and this will give us a little bit more of a formatted method of telling us what processes are running on our system and what they may be members of or what their parent processes were. So we'll see how things are related to other processes that are running on our system. For example, this PSAXJF which is running as PID 1794, was generated from 1793, the bash command, which was from 1740, which is the user PTS port 0 for SSHD, which was generated on PID 976, coming from the SSHD user login. So we see how all of these commands are related to one another, and they all spawned from this particular command, the SSHD daemon itself, who comes from process ID number 1, which happens to be init. So in Linux and Unix systems, each process, as we've talked about, is assigned a process ID or PID or PID. It's how the operating system identifies and keeps track of the processes that are running either by user or by system. So if we want to get the PID of a process, we can do that with the pgrep command. So for example, if we wanted to do pgrep, let's go ahead and clear this. If we wanted to do pgrep on bash, it should tell us that the bash command 1794, if we do a psaux and we grep on 1794, we'll see that right here the bash command is 1794, which matches my pgrep command. And again, remember when we talked about the fact that the init command is process ID number 1, if we do a pgrep init, it should verify that our init process is process ID number 1. And like we talked about, it's responsible for spawning every other process on the system. And the later processes are given larger PID numbers. So that's a way of viewing that all processes that are underneath of init are sub-processes, whereas init is the parent process for everything on the system. A parent process, consequently, can be referred to as a parent PID or a PPID. We can see the PID and PPID in the column headers in many process management applications, including the ones we looked at, top and htop. Now, once we have that information, for example, so let's do a psaux and we'll grep for cron. And cron does happen to be running, and let's keep an eye on process 1292. And the reason we're picking on cron is because it's a non-important in terms of system stability process that we can screw around with without harming the functionality of our system. So what we can do, if we want to stop cron without issuing the stop command, we can actually kill it. We can kill the PID of the target process that we want to kill. So when we looked at psaux on the cron process, and we saw that it was 1292, what we could do is we could just do a kill on 1292. But watch what happens when I try to kill the cron process. The operation is not permitted. And why is that? Because the root user is the owner of the cron process. So in order for you to execute or send a process signal, which is what kill is, it's sending a signal to a process, you have to be the owner of that process. In this case, root happens to be the owner of that process. So the only way to do that would be to do a sudo kill 1292, and that's if the user is permitted to use sudo commands, which in this case it is not. What I'd have to do here is I would have to su to root and log in as root in order to kill a command that I own. So what kill does is kill sends what's called a signal, and a signal is are different ways of sending messages to an application that it's running, and there are a number of them. In this case, what kill does is it sends what's called a term signal to the process. It tells the process, hey, please terminate. It allows the program to perform cleanup operations and exit smoothly if it's possible. We can escalate that by sending a kill signal to the kill process. So now, by default, we've sent kill term. We could do a kill-kill and then the process ID, which I'm going to get an error on here because I'm not the owner of the process. We'll do this in a second. But it's a way of sending the kill signal. It's a special signal. So it's not sent to the process. It's given to the operating system kernel which is told to shut down the process. It's used to bypass programs that ignore the signals that are sent to them. So each of these signals that we're talking about has an associated number that we can pass instead of a name. So for instance, we could pass -15 instead of term, or -9 instead of kill, which would send those particular signals to the process itself. But they're not only used to shut down programs, they can also be used to perform other things. So for example, some daemons will restart when they're sent the hup or hang up signal. Apache's one. Let's see if our cron is. So let's do a sudo or an su dash. We'll log in as root here real quick. And let's do a kill on -hup to 1292. And now if we do a ps-aux grep cron, we'll see that cron has restarted. So cron will run if you happen to send it a hup signal. It'll stop and restart. What if we want to know a list of all the signals on our system? Well, we can do that by just doing a kill-l. And a kill-l will tell us all of these particular items that we could send to our running process or to the kernel, depending on whether we're initiating something that's a hard stop or just a hang up and restart. Finally, one of the things that we want to be able to do, there may be times that we have a process that is running and causing our system load or our CPU to run hot. In those cases, what we can do is we can reprioritize a particular command so that it runs in something that's called nice. So we use the nice command. It only works when we're beginning a new program to run nice. Otherwise, we have to do what's called renice. So in order to alter the nice value of a program that's already running, we use a tool called renice, and we give it the renice value that we want. So for example, we do renice 10 and then 1292, which was our cron PID. So we're saying that the process old priority was 0 and the new priority is 10. So when we look at our cron, we should see that cron is still running, but what it won't do is it won't run at the old priority of 0, which was exactly middle of the road. Now if we're starting an application, we can start an application by presenting, so if I wanted to do nice-n, which tells it what value I want it to start at, and I want to start at the lowest priority, then I could do bin bash. And then if I do a ps-aux and grep on bash, I'll see that I have two of them running, 1794, which is my user one, and then one that I started as root that's running bin bash. It's also running at the lowest priority that I could possibly run. I'm going to exit out of this, and my bash prompt comes back to normal. So keep in mind that process management can be a little bit difficult for new users to grasp because the tools used are different from what you might see in a graphical counterpart like in Windows. However, if you just keep in mind that if you want a really easy view of everything that's running on the system, top and htop can allow you to pick out what happens to be running in the first 10 or 20 processes on the system, and that in order to manipulate processes you need the process ID, and if you want to manage those processes you have to be listed as the owner of it, and you can use ps, kill, nice, and renice to manage those processes. That tool set will provide you with the basic tools that you need to manage all user and system processes running on your system. That's all there is to it. My name is Terry for Linux Academy.